Hi friends, welcome to Kodai Linux. I'm your facilitator Murali. So in today's session we are going to learn about command line arguments. What are command line arguments? How they are useful to the script. And what is an interpreter line or shebang line and what is its significance? Command line arguments. What are command line arguments? These are the arguments that we pass while invoking the shell script. When invoking the shell script, whatever arguments we pass along with the shell script, they are known as command line arguments. While working with them, we will realize the importance or significance of these command line arguments. Okay. How are command line arguments recognized in shell scripts? There are predefined variables in shell scripts which store information related to command line arguments. See, not only shell script, in many other programming languages, they support command line arguments because command line arguments provide flexibility. They make the programs work non-interactively. So we are going to realize that when we get into working with the command line arguments. The variables and their significance is as given below. The variables means the command line argument variables. The variables which stores the information about command line arguments. $0. The variable $0 stores the name of the shell script. The shell script that we are executing, that shell script's name itself is stored in $0 variable. $1 first argument to the shell script. $2 second argument. $3 third argument, and so on. Okay. $@ or $*. $@ or $*. These variables, they store the list of command line arguments. The list of command line arguments which we pass along with the shell script when we are invoking the shell script. That is stored in $* or $@. $#. This variable stores the number of command line arguments. Okay. There is a command called shift command. What is the purpose of this shift command? The shift command is used to remove the first argument from the list of command line arguments. Okay. Shift followed by positive integer removes the number of arguments from the beginning of list of command line arguments as indicated by the positive integer. For example, shift followed by 3 would remove 3 arguments from the beginning of the list of arguments. So list of arguments are what? The arguments that are passed to the shell script. Okay, they are the list of arguments. From that list of arguments, shift is going to remove the number of arguments as indicated by the positive integer that follows the shift. So if you are just giving shift, shell script is going to assume that it is shift space 1. So it is going to remove first argument only. So just executing shift would remove the first argument. By default, it will remove only the first argument from the first leftmost argument. Okay, from the list of arguments that are passed to the shell script. Okay. So if you are giving shift space 4, this would remove first 4 arguments from the list of command line arguments that are passed to the script. Next, interpreter line or shebang line. What is the significance of this interpreter line? We can specify a special line called as interpreter line as the first line in the shell script. So what is the significance? So the before significance, okay, let us look at the syntax of this line. So it would be like #bang /bin/ksh. That is the reason it is also called as shebang, #bang. So shebang. Okay, so hash bang means what? The exclamation symbol. Okay, so when I am specifying a line like this, hash bang followed by the absolute path name of the shell program. Absolute path name of the shell program. Okay, then the shell which begins to execute the script, that is going to load this particular shell. Let us suppose it is the bash that starts executing the script. Okay, as soon as it sees this interpreter line as the first line, then what it does, it understands that whatever is followed by hash and bang, that is it is a name of the shell process in its absolute path name. So it looks for that KSH and loads it and gives the control to it to execute the further lines in the shell script. Okay. This line serves as an instruction to the shell that starts processing the shell script to load the indicated shell and allow the newly loaded shell to interpret the script. Okay, so we are going to work with this interpreter line also. Let's meet at the $prompt. Okay, let us work with the command line arguments. Okay, we have our shell script that we worked during our previous session. Okay, let us take this check employee.sh. Okay, what does this check employee.sh do? Okay, it accepts the name of the employee. Okay, sorry, first it accepts the name of the file. Okay, and then it accepts the employee ID. Okay, so it displays a message, please enter file name, then accepts the file name, displays the message, please enter employee ID, then accepts the employee ID, and then it does whatever it is supposed to do. Fine. So this is what it does. But we can use a technique called as passing of command line arguments. Okay, we can use a technique called as passing of command line arguments. So by using the technique, what we are achieving means, one thing that we are achieving is that we can make the script non-interactive. That is one thing, right? So there is no requirement for the script to prompt for your entering the file name, then prompt for your entering the employee ID, and then do the necessary task. So that is avoided. That is one advantage. Another advantage is that just imagine that you are scheduling the script to be executed at some time. Okay, in that case, who would be giving the input, right? So in that case, if you are passing it as a command line argument, so the script, you are executing the script and there is some predefined command line argument. So you are always passing as a command line. Also in that script, you are giving command line arguments. That way it is able to take the input and then it is able to do the task that it is required, by it, right? So that is another instance. So when you are scheduling a script to be executed, then also then at that point of time you can't expect the script to accept input from someone, right? So it should work non-interactively. So that is another instance wherein this command line argument would be useful. Okay, fine. So let us start working with the command line arguments. Okay. Let us work with the file check employee underscore cla.sh. So this file we are going to use for, this is a copy of the check employee.sh. Okay. So this we are going to use for working with the command line arguments. Okay. Okay. So this line we are removing, accept employee file name and employee ID, not from user but from as command line arguments. Okay, and check if the employee ID is there in the file. If present, then display employee record. Okay, these 4 lines I don't want. Colon sc or set number. So this colon set number would set the line numbers. Okay, so any colon command we want to give, no, then what we need to do, see, I am actually in the insert mode. Okay, so in insert mode, whatever I type, that gets inserted, right? Okay, so I am in the insert mode. So to come back to the command mode, I press escape. That's all. Now colon set number, it would set the line numbers, okay, for my script. Okay, from 4th line to 7th line, that is 4, 5, 6, 7, 4 lines I want to remove. dd, small d, small d, small d followed by another small d will remove 1 line, will delete 1 line. But how to delete 4 lines? Prefix that dd with 4. 4dd will remove 4 lines, current line and the next 3 lines. Okay, 4dd. So we have removed 4 lines. Okay, we know that the information about the command line arguments is stored in some special variables. They are $0, $1, $2, $3 and so on. So wherein $0 stores the name of the shell script itself, $1 the first argument after the shell script. That is, we would be specifying the shell script name followed by the list of arguments, right? Argument 1 space argument 2 space argument 3. That is how we specify the command line arguments, right? Okay, so the first argument would be stored in the special variable known as $1, second argument $2, third argument $3, fourth argument $4 and so on. And the list of the arguments would be stored in $star or $$, or $. And the number of arguments that would be stored in $hash. Okay, so a script which is handling command line arguments, okay, in that script it is the duty of the programmer to check that if the user doesn't enter the right number of arguments, the script should prompt about the same. That is, the script should prompt that the user has not entered the right number of arguments. How do we do that? So the number of arguments is stored in $hash. Okay, in this case, how many arguments I expect? 2 arguments, right? So if the argument hasn't entered 2 arguments, then I have to prompt him, right? So how I do that? If test $hash is not equal to 2. Recall our previous session, wherein previous to previous session, wherein I explained about the test command, right? And the shortcut for test command is a pair of square bracket, within which I can specify the relational expression, right? So if test $hash not equal to 2, that is, if the number of arguments is not equal to 2, then okay, and you very well know that -ne is the not equal to operator, that is numerical comparison not equal to operator, right? When you want to compare with a number, so 2 is a number, right? $hash also number of arguments. So when you want to do the numerical comparison, okay, then you need to use this operator -ne for not equal to. Okay, and we have seen -eq for equal to, -ne not equal to, -ge greater than or equal to, -gt greater than, -lt less than, -le less than or equal to, right? Okay, if $hash not equal to 2, then we can display some usage information like through which we are educating the user as to how he is supposed to, she or he is supposed to execute the script. Okay, usage is like $0 followed by file name. So this expects file name as the first argument and employee ID as the second argument. So we are educating the user as to how she or he is supposed to execute the script. Then exit 1, 5. Okay, so If $hash not equal to 2, meaning if the number of arguments is not equal to 2, then we are displaying a usage information wherein we are telling you need to execute the script like this, like script name followed by file name followed by employee ID. Okay, maybe. Okay, script name, file name, employee ID, and then we are terminating the script. So exit command would terminate the script. Okay, so with exit command we are sending the value 1. So 1 is the exit status we are sending. Okay, we learned about exit status. We know that when a process terminates successfully, it returns an exit status of 0, and when a process terminates unsuccessfully, it returns an exit status between any value between 1 and 255. So here I want to tell through my shell script, I want to tell due to some reason this shell script is terminating unsuccessfully. What is the reason here? The reason is that the user has not entered the right number of arguments, the expected number of arguments. So I'm giving an usage information, fine, but I want to send an unsuccessful exit status. Okay, which would indicate that this shell script process has terminated unsuccessfully. It has not done its task. It has terminated. It has aborted. It has terminated unsuccessfully. So I want to send an unsuccessful exit status. So I'm sending the value 1. Okay. So in case if this condition is false, it means that $hash equal to 2. Then this condition would be false. If the condition is false, what I need to do? I want to get the F name and the EMP ID, right? So F name is in the first argument and EMP ID is in the second argument. That is what is my expectation, right? So even in the usage information what I am giving, this shell script should be executed like the script name followed by file name followed by employee ID. So what I want to do, I want to store the first argument in the variable F name and the second argument in the variable EMP ID. Okay, so how do you do the variable assignment? F name, the name of the variable, equal to first argument. In which variable the first argument is stored? $1, right? So $1. Then EMP ID, in which variables the second argument is stored? $2. So F name equal to $1, EMP ID equal to $2. That's it. Okay. So now, so wherever I am referring to $F name, it refers to the first argument that I passed. Wherever I am referring to the EMP ID, I am referring to the second argument that is passed. So this is what is the changes you need to do when you are handling the command line arguments. Okay, fine. So let us work with the script. Let us execute the script. /chk employee underscore CLA.sh. So it is giving the usage information, usage /chk employees underscore CLA.sh, file name, employee ID. So this is how the script has to be executed. So through the usage information, the script is telling that, okay, the script has to be executed in this way. That is the script name followed by the file name followed by the employee ID. Now I know how I need to execute the script. And what is the exit status that is returned? That is 1. The exit status returned is 1 because we returned the value 1 with the exit command. Okay, whatever value. So exit will do two things. Okay, when I give a statement like exit 1, one task done by exit is to terminate the script. To terminate the script at that point. Then the second task done by the script is to return the value 1 to the parent process. To the parent process, the parent process here is shell. because when you are executing a shell script, okay, the parent shell will create a child shell. A parent shell will create a child shell, and then it will give the control to the child shell, and child shell will start executing the shell script. So now when it is returning the control back, when the child shell is returning the control back because of the exit command, okay, so it is going to terminate itself. The child shell is going to terminate itself, and it is going to return the control back to the parent shell. When it is returning the control back to the parent shell, it is going to return that value 1, which is passed on with the exit command. Okay, so that 1, the parent shell is going to receive it, and then it is going to store in its variable $? So now we are in the parent shell. The script is terminated, right? Now we are in the parent shell. In the parent shell environment, the $? Variable would be there. So that value is 1, because the parent shell has stored that value 1 in the $? Variable. Okay, now let us execute it again, now by passing the proper parameters. Okay, so employee dot data, and then the employee ID, okay, maybe 75. Okay, so I'm entering the file name. As the first argument, I'm entering the file name, that is what is the requirement, and the second argument, I'm entering the employee ID. Okay, so employee.data. So it is working in the usual way. So only thing is that here the only difference is that instead of shell accepting the input, read command, that is, instead of shell prompting to enter file name and accepting the input using the read command, again prompting for employee ID and accepting the input. Now the shell works in such a way that, okay, you can enter the whatever inputs, whatever values the shell needs to work, those values you are supplying in the form of command line arguments or positional parameters, and now the shell has the capability of handling those command line arguments. Okay, so we have worked with one example concerning the command line arguments. Now let us work with yet another example concerning the command line arguments. Now I want to write a script, okay, which would work like this. Okay, I want to write a script called mygrep.sh, which would work like this. Like to this script, I can pass first argument, I would be passing the file name. As second, third, fourth, fifth, so on, those arguments, I would pass a set of patterns. And this script, what it would do, it would look for these patterns in this file, and then it would give the output. Okay, this script I am writing for understanding the significance of shift command. So what does the shift command do? Once we are through the looping control structures, okay, we would work on couple of more practical examples concerning the shift command. But now let us just work with this particular script. Okay, so vi mygrep.sh. So what is the purpose of this script? This script receives file name and then a set of patterns as command line arguments and greps for the patterns in the file. Okay, so in this script also I need to take care of insufficient arguments. If the user doesn't enter the right number of arguments, what we need to do. So for that, what is the variable? Which is the variable which stores the number of arguments? $hash. Right? So if test $hash is less than 2, because minimum 2 arguments should be there, right? One is file name and another is at least one pattern. Okay, so it should, bare minimum should be, it should be 2. It should not be less than 2, right? So if $hash less than 2, then I want to display a usage message So I want to set tab stop equal to 4. Okay, fine. Now I want to display a usage message, echo usage $0 followed by file name followed by pattern 1 followed by optionally pattern 2, pattern 3 and so on. Correct? Fine. So this is the usage message we are displaying. Then exit 1. Not necessarily 1, between 1 and 255. It can be any integer. 5. So we have taken care of the erroneous scenario if the user hasn't entered the right number of arguments. So now what we need to do, we want the file name, right? So we want the file name in a variable. Okay, so f name equal to $1. So the first argument contains the file name. It should be containing the file name. So that we are assigning to f name. Now we no more want the first argument. From the second argument onwards, what it is the list of patterns. So we want that list of patterns. Okay, so but we want to do away with the first argument. How do we do away with the first argument? We have the shift command. Here shift command comes to our help. Shift 1. Even though specifying 1 is not mandatory, if you just execute shift is going to execute with the argument 1. So it is going to shift 1 argument, meaning the leftmost argument it is going to remove. The first argument it is going to remove. Okay. So after shift 1 is executed, what would happen? From the list of arguments, that is $* or $@, what is going to be removed? File name is going to be removed. So as a result, what would $* would contain? $* or $@ would contain? They would contain the list of patterns. Okay. So that list of patterns, I want to assign it to one array. So this is an array assignment statement. This is an array assignment statement. How do you create an array? Let me just come out of the script for just quickly showing you creating an array. Planets equal to Mercury, Venus, Earth, Mars. Okay, fine. So now an array called as planets is created. The value of which is 4 elements: Mercury, Venus, Earth, Mars. Okay, so how do you know that this is an array? Very simple. I want to access all the elements of the array. Then what I need to do? $planets or star. Both I can use. Then it would display the dollar. Oh, here I have made a mistake. Square bracket. Okay. So $planets that would display the elements of the planets. Okay, $planets instead of I am giving 0. Mercury, I am giving 2. That would fetch you Earth. So subscript 0. Planets of 0 is the first element. Planets of 1 is the second element. Planets of 2 is the subscript start from 0. Okay, planets of 2 would be the third element, and so on and so forth. Okay, what if I want to get the number of elements? It's very simple. Don't think that number of elements would be like planets of hash. No. Planets at the rate means what? List of elements. For that list of elements, if you put a hash, it would give you the number of elements. Okay, so you would get the number of elements. How many elements are there in this array? 4 elements are there: Mercury, Venus, Earth, Mars. Right? So the number of elements is 4. So, but if I give something like planets of 0 refers to what? Mercury. So with regard to that, in that context, what would that hash do? It would find the length of the string with reference to the context of a particular element, it would find the length of that string. Length of the string Mercury is 7. Let us check one more thing. No, let us check for one more element. No, like let us check for Mars. Okay, planets of 3 refers to Mars, right? So whether the length is 4. Yes, the length is 4. So as if you are specifying a particular element which is a string, then in that context it would find the string length and it would return that string length. Okay, so this is working with an array. So array name equal to within bracket the list, right? That is how you work with an array. Now let us go to our code .sh. So in the similar vein, what we are doing, so what is the list here? Where is the list? In the $. So within bracket, I am giving $. So $* is nothing but a list. So within bracket there will be the list of elements separated by space. So patterns, when that list of elements separated by space within the bracket is assigned to patterns, then patterns would be created as an array. So shell would create patterns as an array. So patterns of 0, patterns of 1, patterns 2, patterns at the rate, everything would be applicable, right? Okay. So now what I want to do, on these patterns, what I want to do, I want to, okay, see, these patterns, what it would be like, echo, let us just try to display the pattern, okay, echo $patterns of at the rate. Here I have done a mistake. What is that? I should give that curly brace after the $, right? $patterns at the rate. Let us try to display this. Okay. So I am executing mygrep.sh. It's giving permission denied because execute permission is denied. How do we give the execute permission? For the file owner, add execute permission for the file mygrep.sh. Fine. Now ls-l mygrep.sh. Yes, now execute permission is there. See here. Execute permission is there. I have added the execute permission. Let me clear the screen. /mygrep.sh. So it is displaying the usage information /mygrep.sh. Okay, and it has returned the value 1, exit 1. So mygrep.sh, file name, pattern 1, pattern 2, pattern 3. This is how we are supposed to execute this script. Okay, let me now execute it properly as required. Okay, file name employee.data. Okay, 45, 75, 83, okay, 90, like this. I am entering a set of patterns. So file name and then the set of patterns. So what I am displaying only that list of patterns, right? I have stored that list of patterns in an array. I am just displaying the contents of the array. So the contents of the array is proper. So the array is properly created. So that is what I wanted to check, right? vi mygrep.sh. So the array is properly created. So this echo statement is not required. Okay, that echo statement was just for the purpose of checking whether that array is properly created. So now what I want to do in that array, if you see, every element is separated by a space. Okay, but what I eventually want to do, I want to separate all these elements by pipe symbol so that with egrep I can specify this pattern. Okay, so that is my point. See, with egrep, when you want to match multiple patterns, what you need to do, you have to separate every pattern with a pipe symbol. Pipe is known as alternator. That is a extended regular expression. So when in our grep session, earlier I have delivered a session on grep, right? So in that grep session, I have explained about egrep. I have delivered a set of sessions. So 4 sessions on grep I have delivered. So you can go through those sessions for understanding about the grep. Now what is our requirement? We want every pattern to be separated by pipe. Now they are separated by space. So how do you translate the space characters to the pipe characters? So when you want to do some translation of some characters from the input line, when I want to translate a set of characters to set of some other corresponding characters. So what is the answer for that? What is the command which can do that? There is a command called tr command, right? So with the tr command we can very well do that. So what I will do, I'll give paths equal to then dollar bracket, either dollar bracket or backtick, echo, and then I will send the patterns, so dollar patterns, pipe it to tr. In that dollar patterns, what I want to do, I want to substitute all the space characters to the pipe character, because I want the elements to be separated by pipe, right? I want the elements to be separated by pipe. So I am substituting all the space characters to pipe characters. Fine. Then that ends, correct? So let us try to understand about this line. So look at the right hand side. Echo dollar patterns. I am sending the that string, that line to the through the pipe. I am sending it to tr command. So tr command receives that line. In that line, what would be there? The set of patterns separated by space. What I am telling through the tr command, by the tr command, what it specifies, like wherever space is there, replace that with pipe. That's it. So wherever space is there, it will replace with pipe. So it's like instead of pattern 1 space pattern 2 space pattern 3 so on, it will replace like pattern 1 pipe pattern 2 pipe pattern 3, and that is what I want, so that I can specify that with egrep. Now what I want to do, I can egrep it. Egrep dollar paths. Then before egrepping, just for our understanding, let us try to display that pattern, paths, dollar paths. Let us look at the script. Got it? Why it displayed only the first element? What is the issue in the script? Here, see, I have just given dollar patterns. Dollar patterns would get you only the first element. Instead, what you need to do, dollar curly brace patterns of at the rate. Only that will get you all the elements, right? You cannot just give dollar patterns. Dollar patterns would get you the element of the base address. That is the first element. But if you want all the elements, then you need to give dollar curly brace patterns at the rate. So that was the mistake I did. Now let us see whether it gets it properly. /mygrep.sh employee.data, then all the elements. Yes, it is getting all these patterns separated by pipe symbol. Correct? So now let us look at it again. Paths equal to, look at the line number 11. Paths equal to dollar bracket echo dollar patterns at the rate. So you are sending that list. The list means what? The set of elements separated by space. The set of elements separated by space. That you are piping it to tr. With tr command, what you are doing? You are translating all the space characters to pipe characters. So wherever space is there, it will translate that to pipe, and the tr would assign its result to paths, because there is a left hand side variable, right? So ultimately in command substitution, what happens? Ultimately, when the command is completely executed, its output would be assigned to the left hand side variable, right? When you are giving something like variable equal to command substitution. So paths would have the value. But I don't need the paths now. If you want, you can just keep that paths, just echo paths you can do. But ultimately what we want to do means, we want to use it in the egrep. And then -w, because I want to look for the whole word. Each of the patterns I want to look for the whole word. I don't want wherever that, for example, employee number 45, wherever that 45 comes, it would display all those lines. I want only that record wherein employee ID is 45. So I want to look for the whole word, because in all those records, after employee ID, colon is there, right? So colon is a non-word character. So it will exactly look for the whole word. So egrep hyphen W, then dollar pats. Okay, then dollar f name. So this would look for the patterns in the file exactly. Okay, let us see. Okay, so it is getting the records that contain the patterns 45, 75, 83, 90. That is what we required, right? So what this mygraph.sh has done, so when you are supplying the arguments, file name as the first argument and the subsequent argument, some patterns to be searched. So what it has done, it has looked for these patterns in this file and then displayed all the matching records. So from this we have learnt certain things like cat mygraph.sh. Okay, so what all we have learned through this script? One thing that we learned is about the shift command. Okay, what this shift command will do. Shift without any arguments would execute shift with one as the argument, the integer 1 as the argument, or you can explicitly specify 1 also, shift 1. What this would do, it would remove the first argument from the list of command line arguments. So after doing that, what happens? The command line arguments would contain only the list of patterns, not the file name, because that file name already you assigned to a variable called fname. You have taken care of that, right? Next, what we want to do, that list of patterns. Okay, why I am assigning it to the array and doing all these things? Because ultimately that list of patterns is there. Okay, but that list of patterns is separated by space. So what I am doing, I am assigning it to an array. Okay, and then I am using that array and then TRs also. See, you can do one more thing also. You can directly give $* also. Echo $* pipe it to TR space pipe. That would also work. You can try that out. Okay, it will work. Okay, and assign it to paths. So no need of in between creating an array also. But I took an opportunity to explain you about array also. Okay, taking this as an opportunity. Okay, so patterns equal to $* within bracket, it would create an array called patterns. How do we access elements of the array? So we have learnt about that. How do we access elements of the array? How to find the number of elements of the array? How to return the list of elements of the array? Everything we have learnt, right? So on the why we are using the tr command to translate all the spaces to the pipe symbol. Okay, and then it assigns it to paths, and paths eventually what does it contain? The pattern separated by pipe symbol. So egrep can handle it, right? With egrep, when I am giving like a set of patterns separated by pipe symbol, egrep knows exactly what it needs to do, because for egrep the pipe symbol or the alternator symbol has got a specific meaning, like it should match all these patterns in the input file and then produce the output accordingly. And we are giving -w option for to match the whole word. Okay, I believe you would have understood this. We have seen two ways of executing the script so far, right? What is that? Let me show you. One is that when you are executing a script, you can explicitly give bash space /mygraph.sh or mygraph.sh. Okay, in both the ways it is relative path name. It is referring to the file in the current directory, script file in the current directory. One is explicitly by specifying bash. Fine. That also would execute the script. Or just /mygraph.sh so and so. So what is the difference in the requirement with regard to both the things? With regard to executing with the bash command explicitly, mygraph.sh script, that script file need not have execute permission. If it has execute permission, no issue, but it is not needed. It is not actually needed. So I am just removing it. Okay, chmod u minus x mygrep.sh. Okay, now execute permission is not there, right? See, you can see the permission string. Whether execute permission is there? No. So earlier it was there. So now I have removed it. So u minus x from the file owner. So this is the file owner part. This is the file owner. The first, see, after hyphen, the first three characters are the third, fourth, second, third, fourth characters. That refers to the file owner permissions. So for file owner, execute permission is there. But here for the file owner, execute permission is not there. I have removed it. So u means file owner minus x. Remove the execute permission. I have removed it. Now I can very well execute with the help of the bash command. Yes, because for executing a script with the bash command, that script needs read permission. Okay, if read permission is there for that script, fine, because bash should be able to read from the script. But when you want to execute the script without bash, okay, when you want to execute the script without bash, then that script needs execute permission. Okay, so if you are not executing explicitly with the bash command, then the script needs execute permission. So that is the reason you remember earlier I would have given the execute permission, right? So now how do you add the execute permission? Remove the execute permission minus, add the execute permission plus. So now I have added the execute permission. ls-l mygrep.sh. Yes, now the execute permission has been added, right? Now I can execute it like this. Okay, so when I execute the script, whether with the bash command or without the bash command, in whatever way I execute the script, okay, what happens means, for the purpose of executing the script, my current shell process would create a child process, a child shell process. My current shell process would fork a child shell process. Current shell process is my login shell. That would fork a child shell process, and it will hand over the task of executing the script to the child shell process. So the parent is what? Bash. How do you know that? ps-f. There is a command called ps command. ps-f. F means full listing. So that would, from that you know that your shell process is your current shell process, or which is also a login shell, that is the bash process. Okay, so it's a bash process. So your bash, when your parent is bash or your current shell is bash, its child would also be a bash. A bash would fork a bash child only. Okay, so its child also would be a bash, but that is a child process. So the child process would execute the script, and once it terminates, once the script terminates, the child returns the control back to the parent, and along with the exit status. Okay, if it falls through the script completely smoothly and executes, terminates normally, by default it would return a value 0. And we have seen occasions wherein I am explicitly returning a value 1, right, with the help of exit command. So then it would return the value 1. Okay, indicating that there has been some issue in the execution of the script due to some issue. Okay, due to some problem. Okay, like you have not entered the right number of arguments. Okay, so in that case it would have returned a non-zero exit status value. So we need to understand that when I am executing a script, for the purpose of executing that script, the current shell process, which is the login shell, creates a child shell. And if the current shell is bash, the child shell also would be bash, and the child shell bash would be executing the script. Maybe I have written a script which is which has got some syntax which is conn shell specific. Okay, so in that case, I want my script to be executed by conn shell. So how do I do that? Even though my login shell is bash, for that purpose I don't want to switch my shell to conn shell. Even though my login shell is bash, but this particular script, I want the conn shell to execute the script. So how do I do that? So let us try to understand that. let me open the file mygrep.sh. Here, first let me see. I told you that when I'm executing a script, okay, then for the purpose of executing the script, the login shell or the parent shell, the current shell would create a child shell, and if the current shell is bash, the child also would be bash. So I will just show you that the child is also bash. Okay, let us execute the script. See, look at the output of the ps command. See, look at the PID, PPID, examine it. See here, PID is 4731. PPID is 4723. Here, PID is 6051 and PPID is 4731. See, what is the meaning of PPID? Parents process ID. So this bash, parents process ID is 4731. Meaning what? The parent of this bash is this bash. Because which is having 4731 as its process ID? 4731. So what is the meaning of this PPID? Parents process ID. So parents process ID of this process is 4731. So which is the process ID 4731? Which process is having 4731 as its process ID 4731? This particular bash. So this bash is the parent of this bash. That is proved. So your child is also bash, and that bash only has executed your script. Okay, that is proved. Okay, but now I don't want my child to be bash, but I want my child to be conch shell. Okay, maybe there are certain syntax. Okay, when you go to advanced level of shell scripting, there are certain syntax which is conch shell specific. So in that case, I want explicitly to run by conch shell. There are certain syntax which is bash specific. There are certain syntax at an advanced level. At an advanced level, where there are certain syntax which is conch shell specific. So I want my script to be executed by conch shell rather than bash. So how do I do that? Let us see that. For that, there is a technique called as interpreter line. So by providing the interpreter line, I can take care of that. Even though I am executing the script from the bash, being in the bash, I am executing the script. But still I can take care that the child would be conch shell. How do I do that? For that, there is a syntax like this: #bang/ Okay, so I want to know exactly in which location that KSH is there. Okay, KSH refers to the conch shell. Okay, the process conch shell. So I want to know which location it is there. How do we find it out? Being in VA editor, you can execute a command, right? In an earlier class also I told you that. Okay, being in a VA editor, we can execute a command. How do we do that? Colon, exclamation, then followed by the command that you want to execute. I want to execute the type command. With the type command, I want to check where KSH is. So type command would tell where exactly the KSH process is located. So we understand that it is located in /usr/bin/ksh. So that would help me to give it here /usr/bin/ksh. So that way I am able to specify the absolute path name of KSH, because this shell should be able to find the KSH shell program unless you give the absolute path name, how it would be able to find. So when you give the absolute path name, it will okay. Under slash, it will go to USR directory. In USR directory, it will look for bin directory. In bin directory, under the bin directory, it will look for a file called KSH. When it finds it, it will load it. Okay, it will load it, and then it will give the control to the KSH. Okay, that is what happens. What happens, let me tell you the sequence of events that happen. Okay. So I'll just type it here over here. Okay, then I'll remove it. So the sequence of events that happen is that the first thing that happens is that bash, the current bash from where you are executing the script. Okay, forks a child bash and gives control to it. That is the first thing that happens. The second event that happens is that the child bash is overlaid by the KSH. By looking at the interpreter line, what happens? The child bash should be overlaid by the KSH. So KSH would be loaded, and what KSH would do? It would overlay the bash. So overlaying means what? It's something like overwriting. So the memory which was occupied by the child bash, that would be now occupied by the newly created, newly loaded KSH process, because of you are giving the interpreter line. So this is what happens, and then the KSH process will take the control and start executing from the PS command onwards. That statement onwards, the KSH would start executing. Okay, this is what happens. So I am removing these two lines. Fine. So this is the interpreter line. Okay. Now let us see how it. Let us execute it and check. Okay. Just clearing the screen. Let us execute the script now. Yes. See, look at the output. The current shell was bash. The parent is bash, and the child of bash is const shell. And from this line, it is very clear that, see, look at this, /usr/bin/ksh ./mygrep.sh, as if we have executed this mygrep.sh with the ksh. The command line has been formed, and it is very informative that it is showing the entire command line that is formed here. So from this, it is very clear that ksh is executing the mygrep.sh along with its the command line arguments, right? So KSH has started executing it. There is no difference, because I told you that only when you go to the advanced shell scripting, you can see the difference between the some of the syntax of the bash and const shell. Otherwise, there is no difference in the syntax, so it behaves in the same way. Okay. So with this, we have come to the end of this session. So in this session, we have learnt about one thing that we have learnt is the command line arguments. And another thing that we have learnt is the interpreter line or the shebang line, and the significance of working with the command line arguments, significance of working with the shebang line or the interpreter line. So I believe this would have been a useful session to you. So please keep working on whatever we learned during all these sessions. Okay. So those who are yet to subscribe, for getting the frequent updates, you can subscribe to the channel, and for getting the notifications, you can click on the bell icon. Okay, thank you. See you in the next class. Take care. Bye bye.